I'm going to go up 4 just a little bit. I'm going to say 4 up is right here. And then 4 down, of course. Just spatially make them equal. All right, now we're going to find the period. The period is going to be 2 pi, always 2 pi, times the reciprocal of the b value, which is 1/3. So the period is 2 pi over 3. And I don't really need that, but I have to have that to find the increments, which is what I must have. So the increments are going to be 2 over 12, which simplifies to pi over 6. All right, so remember my very first tick mark is pi. In my head, that's 6 over 6, y'all. That's 6 over 6, 1 whole. 6 over 6 plus pi over 6 is 7 pi over 6. 7 over 6 plus 1 over 6 is 8 over 6, which is 4 pi over 3. Yes. Remember, that's 8 over 6 plus 1 over 6 is 9 over 6, which is 3 pi over 2. 9 over 6 plus 1 over 6 is 10 over 6. So that was a lot of mental math, and that was a lot of stuff to keep in your head. If you're able to do that super fast, great. If you're not able to do that super fast, you've got to go back and look at the homework. You've got to be able to go from that to here in a fairly decent amount of time. You should not have to write any converting to common denominators on that. All right, do I have 5? 1, 2, 3, 4, 5. I have 5. All right, cool. We're ready to start. Remember, we are drawing sine. Where does sine start? In the middle. Look, I'm just kind of dotting this out with this yellow on purpose because this shape that I'm drawing is not the answer. It's just going to help me. So after the middle, regular sine goes to the top, then it goes to the middle again before it hits bottom. Then it stops at the middle. Now, it is off my screen, but it's on your paper. What did you highlight? What does step 2 say? Where are the vertical asymptotes? On the midline. This middle horizontal line are your asymptotes. So here's the middle. Do we have any dots? Yes, right here. Here's another one. We have one more. That's where it's going to be undefined for cosecant. So we're going to turn this stuff into asymptotes. And y'all know what those are. You've been dealing with those for a couple of years. We have 3 of them. And we do have to state those asymptotes. So we have 3 to list here. So x is going to equal, and I'm just going to list them all together. I'm going to separate them with a comma. The first one is where x equals pi, then 4 pi over 3, and then we got one more over there at 5 pi over 3. Well, where's the regular graph then? The regular graph are the dots that you drew on the top and bottom line. So here's the top. Here's where I drew a dot. We are recycling that dot because that's the vertex of one of the branches. Is there any other dot at the top of the bottom that we need to recycle? Yes, right here. Make sure you're hugging your asymptotes. That behavior never changes. And that's it. That's going to be your cosecant graph. Let's do it again. Let's turn the page.
I have a question.
Sure.
So, how did you get the big parts like 7 pi over 6? What numbers did you use?
See how we started at plain pi?
Mm-hmm.
I made that in sixes in my head. This is 6 over 6 because it's one whole. That's 6 over 6. And then my next increment is pi over 6 away. So in my head, I had 6 over 6 plus 1 over 6. So I knew that was the next one. And then the next one is still 1 over 6 away. So 7 plus 1 is 8. So the next one is 8 over 6, but I simplified it. There's a lot going on here, y'all. Yes?
Whenever we do this cosecant kind of line, you don't want us to draw the cosine line, like the
The sign?
You don't want us to draw that?
No, because that's not the graph. This is the graph. Mm-hmm.
We knew asymptotes. If one's like close enough to the level, it's enough to get.
Yes.
Why did you simplify this one to 5 over 6 and not in the one?
I'm sorry?
So in this one we had 2 pi over 12 for one more time in the increment.
Mhm.
So one more put in the normal to then simplify to 5 over 6.
Because look at the warm-up. What was the starting point? Right. I want my bottom denominators to match. That way I can do the math in my head. But here, they weren't going to match anyway, so I went ahead and simplified. Good question. Okay. Let's keep going. Lots of mental practice here, but you're in pre-cal for a reason. You're going to be all right. Before we jump in, let's analyze what we're looking at. So let's just look at number 2. Let's just talk about number 2. So number 2 is secant. What's that the reciprocal for? Cosine. Very good. Think about cosine. If I graphed cosine according to this A value, would it be opening up or opening down? Yeah, right? It's reflected. Are you going to have to do some factoring on problem 2? Yes. What is the B value? That's the A value. What's the B value? It's 4. Oh, I'm so sorry. The A value is 4. What's the H value? I don't know. I know for sure it's not 3 over 4 because you got a 4 hanging out there. All right, we'll come back to that. Let's look at problem 3. Problem 3 is secant again for cosine, but this time is cosine going to open up or down? Very good. Are you going to have to factor on that? For sure. What's the B value? It's 3. What's the A value? 1. Mm-hmm. When there's not a number in front, it's understood to be 1. What about problem 4? Ooh, problem 4 is cosecant. What's that the reciprocal for? It's for sine. But remember, sine's going to be reflected, so it's going to go down, then up. Are you going to have to factor on problem 4? No, you're not. What's the B value on problem 4? 1. What's the A value? The A value is 3. Or negative 3, yes. What's the amplitude? Just 3. Always positive. So yes, amplitude's always positive. All right, let's go back up and knock out problem 2. All right, remember we talked about how we're going to have to factor, so let's go ahead and do that. You're going to multiply this by the reciprocal. All right, here we go. So I already drew the little shape. I know for sure it's going to start at the H value, but it's not going to start at the K value because it opens at the bottom. The midline is 2. If it opens at the bottom, it's going to be 2 places below 2. So that's going to be at a 0. Because remember, K is the midline. Your amplitude is 2. 2 places up, 2 places down. Let's draw these horizontal lines. Here's my midline. This is going to be my positive 2, my K value. 2 places below is going to be 0. 2 places above is going to be 4. Look how close I have these together. That takes care of the y-axis. Let's work on the x-axis. Find the period. 2 pi times the reciprocal of b is going to give you the period. But remember, it's not really about this. It's about taking this number and immediately multiplying it by 1/4, because that's going to tell you the numbers for the x-axis. So I'm going to start at -3/16 because that's where it starts, the h value. But the next one is pi/8 away. So in my head, I'm moving this far because that equals that and my denominators match. So a -3 plus 2 is -1. -1 plus 2 is +1. Then let's add 2 again. 1 plus 2. 3 plus 2. And then I think I can stop. Do I have 5 tick marks? 1, 2, 3, 4, 5. I do. That's all I need. All right. So remember, from here, any dot that we draw on the center line, we have to change to an asymptote. So let's go ahead and draw the shape of cosine. Remember, we talked about how it starts at the bottom, so it would start right here. Then it's going to start to ascend. Then it's going to start to descend. How many dots did we draw in the middle? 2. You got 2 asymptotes. Let's draw vertical lines from that. And we have to list your asymptotes. On your quiz next week, you're so going to have to list your asymptotes. And it's always x equals. Remember, it's x equals -pi/16. And then +3 pi/16. Also remember, you're going to recycle the dots that you drew on the top and the bottom. I drew a dot on the bottom right here, so I'm going to draw it. It's going to look like a little hook, because remember, over here are more asymptotes, over there are more asymptotes. I just drew a period. So here's another point I need to recycle, and then you got one more right here. Let's go through it one more time. Then we'll stop and talk about some questions. Here we go. Next one, we already determined it's going to behave like a cosine. We already talked about how we have to factor, so let's go ahead and factor. Okay, so remember cosecant, that little shape we drew, that reminds us that we do not have it start at that K. It doesn't start in the middle. It starts at the top. Now remember, I'm going to leave that blank for a moment. If K is your midline at -1, what's your A again? 1. Then if K is your midline and it opens up, then this graph is going to start at 2 pi over 9, 0. All right, that's all I need to section off the y-axis. Here's -1, the midline, one place below the origin. I'm going to use my amplitude to go one place up, which is going to be stuck right on the x-axis, see? And then one place down. Yes. The K value is the same K value being added or subtracted at the end. The high line and the low line?
Like the vertex, like the 0.
Oh, yes. So you'd either add or subtract for a cosine. Yes, yes, yes. All right, what's next? The x-axis. How are you going to get the x-axis? From the increments. How do you get the increments? From the period. So, 2 pi times, wait, what is b again? 3. So multiply by 1/3. So my period is 2 pi over 3, which is great to know, but that doesn't help me with the x-axis. I have to take that and multiply it by 1/4. So I get 2 over 12, which is pi over 6. That's my increments. Friends, where are we starting? We're starting right here. How far apart are we going? Right there. Lots of mental math, but y'all can do this. You made it this far because you have the capacity to do this. So, I can't make a 9 into a 6, and I can't make a 6 into a 9. But in my head, I can make them 18ths. So this pi over 6, multiply the top and bottom by 3. So in my head, I'm going to move this far apart. I'm going to write 2 pi over 9 right here, but in my head, I'm going to think about 4 pi over 18. In my head, it's that. On paper, it's that. In my head, it's that. Let's go ahead and write positive 2 pi over 9. I'm going to write it all at the top. But remember, that's what I have in my head. So 4 over 18 plus 3 over 18 is 7 over 18. That's the next one. All right, here's another one. 7 plus 3. What's 7 plus 3? Yeah, but y'all don't write 10 over 18. What are you going to write? There you go, 5 pi over 9. Here's another one. Remember, that was 10 10 plus 3 is 13. That's a prime number, so that's not going to simplify. But what's 13 plus 3? Yeah, that's going to be 16 over 18, but you can't write that. What are you going to write? 8 pi over 9. All right, look. So remember, we're going to draw the dots for cosine. Anything that we draw on that line right there is going to turn into an asymptote. We start high. We descend, reach the bottom, then come back up. How many dots did you draw on the midline? Yes. You have 2 asymptotes. Let's go ahead and write those down because you'll have to. All right, so what is x going to equal? It's going to equal 7 pi over 18 and 13 pi over 18. All right, let's draw the branches. We know the branches are going to occur where there's dots at the top and the bottom. There's a dot up there. So I'm going to draw a little hook because it does eventually go back up, but we just don't see it in this period. There's a full shape right there, and then one more hook over there on the right side. Do y'all know what I mean when I say hook? You got to kind of show it coming back up. Looks like a fishing hook to me. Any questions? I'm going to pass some stuff out to you. Please try number 4. Yes, Jack.
I'm so confused on the state marks part.
On which part?
The state marks, with 2 pi over 9, that's
Okay.
I just don't know how to use those numbers.
Okay, let me show you before I pass the stuff out. You guys go ahead and get started.